Hello everyone, welcome back to Math Wars by Vishal. So the wait is finally over, right? Because the JEE Mains 2026 session was started today, and both the morning and also afternoon shifts were completed. And I'm not going to comment anything about the difficulty level of the both papers because obviously the difficulty level of the paper depends on the individual student. So let's not discuss about that. So in this video, I'll try to discuss the questions which might make students think twice before answering. So I'm not going to discuss the entire paper. So I thought maybe I'll bring only the highlighted questions of the day. So let's see the questions one by one. So let us see the first question for this video. And this was asked today, and this is a question which was almost similar to the question which I discussed in the part one 3D geometry when I discussed the top 10 PYQs. Okay, so once again, you can go through that. This question was there. Almost a similar question was there. So let us try to see the question solution here. There are two straight lines L1 and L2 which are intersecting in the XY plane. Then the value of A plus B is. So first thing is we have to solve for the point of intersection of the two straight lines, and we know the method obviously that you will be taking the first one as is equals to some K1, and you will take the second line as is equals to some K2. From there you will get the general point on the first line. So I'm going to mention that on L1 the point is directly 2K1 plus A, comma 3K1 plus 2, comma 6K1 plus B. And similarly, on the line L2, the general point can be taken as 3K2 plus B, comma 6K2 plus 7, comma 3K2 plus 1. Now, clearly, they are saying that the two straight lines are intersecting, first of all. Moreover, they are intersecting in the XY plane. So, first, let us try to concentrate on intersecting part. Now, if they are intersecting, definitely we can equate all the corresponding coordinates, right? So let's do that. What we get is 2K1 plus A is equals to 3K2 plus B. Let's take it as one condition. And if you equate the y coordinates also, you get something like this. 3K1 plus 2 is equals to 6K2 plus 7, or else I can write this as 3K1 plus 6K2 is equals to, 3K1 is equals to 6K2 plus 5. And similarly, I can equate the z coordinates also here. So if I equate the z coordinates, I'm going to get this as 6K1 plus B is equals to 3K2 plus 1. Okay, let us keep all these conditions aside. Now let's come to the interesting part here. They said that the two straight lines are intersecting in the xy plane. Okay, let's see the rough diagram so that we'll get more clarity. This is line L1, call it L1, and let's call it L2, line 2, and both are meeting here. Okay, this is the line L2. And now we know very well in the last video also I have told you, right, that if the straight line is intersecting in xy plane, obviously z coordinate can be equated to 0. That is why what I'm going to do is I'm going to equate the z coordinates to 0. Okay, so if I equate the z coordinates to 0, one condition I will get is 6k1 plus b is equals to 0. Otherwise, k1 is equals to minus b by 6. Let us keep it aside. And I also can equate the z coordinate of the second line as well to 0 because that is also lying on xy plane. So from which you get 3k2 plus 1 is equals to 0 implies k2 is equals to minus 1 by 3. K2 is equals to minus 1 by 3. Okay. Now from here, since K2 is equal to minus 1 by 3, I'm sorry. So now what I'm going to do is I'm going to put this K2 value in one of the equations. So look at that. I'll substitute it here so that I'll get K1 value from there. So 3K1 is equals to 6 times of K2 value is minus 1 by 3 and plus 5. Finally, 3K1 is equals to minus 2 plus 5. So we get K1 is equals to 3K1 is equal to 3. So K1 is equals to 1. So we have solved for K1. And but I can take this K1 is equals to 1 and put it in the condition that we have just got here, that K1 is equals to minus B by 6, but K1 is equals to 1 implies B will be is equals to minus 6. So successfully we have found out one of the required value. But more importantly, by using the condition one, I can put the values of k1 and k2 and get the value of a also, right? So let's do that here. Observe carefully. So it is 2 times of k1 is 1 plus a is equals to 3 times of k2 is minus 1 by 3 and then plus b just now we have got. Okay, so finally what we get is a plus 2 is equals to minus 1 minus 6, so which means a is equals to minus 9. So finally we have got both the values a and also b as minus 9 comma minus 6 respectively, but the required question is what? Modulus of a plus b, which is going to be option 1. Okay, so as you see, the question is not difficult. It is just similar to the question which we solved in the part 1 of 3D geometry, but in there the question was the lines were intersecting in yz plane. There we equated x coordinate to 0, but here it is xy plane, so I equate z coordinate to 0. So try to be careful. Okay, let's see the next question. Now, this is a very easy question if you recall the property that from definite integration. So whenever we have an invertible function f of x, something like this, integral a to b f of x dx plus integral f of a to f of b f inverse of x dx. This will be always is equals to b into f of b minus of a into f of a. So this was our formula, right? Obviously, it has to satisfy the conditions of integration. Moreover, it has to be invertible function because we are talking about if inverse function. Right? So this is a basic property from what? Definite integration chapter. But don't directly apply the property because it might look exact in the similar way, but sometimes paper setter might try to trap you by not putting the limits exactly the way it's supposed to be. Okay, so let's just try to verify. Don't blindly put it every time directly the answer. Always try to make sure it is exactly in the formula, only then you substitute there. Okay. So what I'm going to do is obviously I'll take a is equals to 2, I'll take b is equals to 4, and then uh, this is your function f of x. Okay? But we know how to find out f inverse function, right? So let's take f of x, which is equals to square root of 2 power x minus 4, which is equals to the usual process for finding inverse. So from there you get 2 power x is equals to y square plus 4. So finally you get x is equals to log of y square plus 4 to the base 2. So finally, we get x value as this, but x is nothing but here f inverse of y. And if I interchange the variable, replace the variable, I get f inverse of x is equals to log of x square plus 4 to the base 2. So we have found out the inverse of this function here. Okay. And then moreover, it's exactly matching, right? This is f inverse function here. You can notice. And then let us try to verify the limits are also satisfying or not. Okay, as I told, they might try to trap you in this question by changing the limit. So let's try to be very careful. So if this is a, this should be f of a here. So let's verify. So we have to find out f of 2 value. So f of 2 is equals to square root of 2 square minus 4, which is equals to 0. So lower limit is satisfying. What about the upper limit? So if this is b, it has to be f of b. Let's calculate f of b, whereas b is 4. So f of 4 should be is equals to square root of 2 power 4 minus 4. That is square root of 16 minus 4, 12. So it should be 2 root 3. So which is clearly f of b value. Now you can notice it is exactly in the form integral a to b f of x plus integral f of a to f of b f inverse of x dx. So directly your formula should be like this. So you can remember the trick like this, right? Multiply the upper limits b into f of b and subtract the product of lower limits. So which means in this case your answer should be 4 into 2 root 3 minus of 0 4 into 2 root 3 minus of 2 into 0, which should be is equals to 8 into square root of 3. Okay, it's a very easy question once you recall the problem. Let's see the next question. So this is one of the good questions which was asked in the morning session of today. Okay, so let's try to understand. The question framing is very simple. That is, the total number of critical points of the function f of x in x belongs to minus 2 pi to 2 pi. But you have to be very careful while solving this question, because if you were somewhat negligent, then you might miss few cases here. Okay, so let's try to be very careful and try to understand properly. First thing, we know what is a critical point, right? So critical point means either the derivative will be is equals to zero, or also it should be non-differentiable. Okay? So a point x is equal to c is called a critical point if either derivative at that point will be is equals to zero, or it might be non-differentiable also. Okay, so let's try to observe carefully. So since the function is a piecewise function and it is changing definition at x is equal to zero, right? I'm going to check for continuity, obviously. So limit x tends to zero, f of x is equals to f of zero or not. I'm going to check that. So limit x tends to 0, f of x is modulus of sin x divided by x, which is equal to f of 0 is already given as 1. But we know that limit x tends to 0, mod of sin x by x is 1. So we get 1 is equal to 1. Hence it is continuous function. Okay. So I have verified for continuity. Now let's check for differentiability at x is equals to 0. Okay. This is at x is equals to 0. Now we know the differentiability test, that is if limit I'm going to write the formula here just to recall. Limit x tends to a, f of x minus f of a divided by x minus of a. So if this limit is existing, directly we can say the function is going to be differentiable, right? And whatever value you get, if the limit is existing, that is nothing but the value of f dash of a. So this is the basic concept of differentiability. And obviously, we have other methods also to check for differentiability, but this is the method generally I follow in any of the question. Right. So let's check for limit existence of this one here. So limit extends to 0 because I'm taking at 0 here. Limit extends to 0. F of x is modulus of sin x by x minus of f of 0. F of 0 is 1 divided by x minus of 0. Follow the formula here. Limit extends to a. F of x minus f of a divided by x minus of a. Now here a is 0. Now, moreover, here I can directly write limit extends to 0 sin x by x minus 1 divided by x. What is the reason? Because when x tends to 0, sin x and x will have the same sign, which makes sin x by x as positive. That is why I remove the modulus sign, and which reduces the question to limit extends to 0 sin x minus x divided by x square. And if you try to use the expansions here, that is limit extends to 0, what is the sin x expansion, x minus x cubed by 3 factorial and so on, minus of x whole divided by x square. So which will give you on cancellation of x, you get limit extends to 0 minus x divided by 3 factorial. But when you put 0, you get 0, right? So which means the limit of this function, I'm going to write it here, limit extends to 0, f of x minus f of 0 divided by x minus 0 is existing, and moreover that value is equals to 0. Okay, so which makes the function actually differentiable here. Okay, try to be careful. At x is equal to 0, the function is differentiable, but here we are not checking for differentiability, we are checking for what? Critical points. So what is the definition of critical point? Either the derivative can be 0, or it is not differentiable. But clearly, as I just told, whatever value of the limit that we get, if the limit is existing, that is nothing but the value of f dash of a. So which means in this case, f dash of 0 is equals to 0. Okay. So which means x is equal to 0 is a critical point. Hence, I'm concluding it is one of critical point. Okay. So try to understand this process here. And this is only one of the point that have checked for a critical point, but there are a lot more points also here. Let's try to be very careful. Okay, now what is the function again? Mod x mod of sin x divided by x. So once again, let's try to recall a simple property here. Whenever we have modulus of f of x, whenever we have modulus of f of x, what is the basic thing there? That whenever we have modulus of f of x, that function might be non-differentiable where f of x is equals to 0. Okay, we just make the input to the modulus function to 0. So at those points of x, the function might be non-differentiable. Once again, I'm using the word might be non-differentiable. Be very careful because sometimes even at that points also the function can be differentiable. Okay, so try to be very careful with the word framing there. Might be non-differentiable. Now, what is our function? When x is not is equals to 0, we have the function as f of x is equals to modulus of sin x divided by x. Okay, so this is nothing but 1 by mod x multiplied by modulus of sin x, right? So if I try to make this sin x is equal to 0, that is whatever input to the modulus. Just now I told you it. Whenever we have mod of f of x, we put f of x to 0. Whatever is input to the modulus, we equate it to 0 and find out the corresponding values of x, right? So clearly, I'm going to make this sin x to 0. So if sin x is equal to 0, what are the values x is equal to n pi? But what is the interval that we are supposed to check? Only minus 2 pi to 2 pi. That also only in the open interval here. Already we have concluded about 0, so don't worry about that. Which means the other two values will be x is equals to plus or minus pi. Okay. But this x is equal to plus or minus pi are going to be definitely non-differentiable points because if you observe, even if you put x is equal to plus or minus pi in this factor 1 by mod x, it is not is equals to 0. Hence, we can say that it is non-differentiable points. So we got two more points here. Okay, and the question is not over it. That's a beautiful thing. Question is not over it. It's a lengthy question. We have to solve still more because here we have tried to find out only non-differentiable points when x is not is equal to 0 because we still need to check whether the derivative can be 0 when x is equals to when x is not is equal to 0. Okay. So let's take that case here. When x is not is equals to 0, we have f of x is equals to modulus of sin x divided by x. Okay. Now I'm going to take one of the case and I will leave the rest of the calculation to you. I will take the case where sin x and x have the same sign. For example, in the interval minus 2 pi to 2 pi, I can say that when x belongs to minus pi to pi, when x belongs to minus pi to pi, I can directly write down mod of sin x divided by x is equals to sin x by x because you just observe the graph of sin x and y is equal to x and you can understand in the interval minus pi to pi the sin x and x will have the same sign, that is why modulus of sin x by x can be written as directly sin x by x. So I'm going to take that case and you try to find out about the remaining cases by yourself. Okay, so in this case when x belongs to minus pi to pi, I'm going to get f of x is equals to sin x by x. Okay. Now let's start differentiating and equate it to 0 because critical point means derivative can also be equals to 0. Now what I'm going to do is f dash of x is equals to, this is x square and v u dash, so x cos x minus of sin x. Now equate this to 0. Since x is not is equal to 0, cross multiply, we get x into cos x minus sin x is equals to 0 implies tan x is equals to x. So which means we have a trigonometric equation here, that is tan x is equal to x. Okay. But this is a trigonometric equation which cannot be solved directly. You have to obviously go for the graph of tan x and also y is equals to x. So let's do the graph and verify. So this is your graph for tan x, a rough graph. This is pi by 2 minus pi by 2. Similarly, this is minus pi, and you can extend the graph, right? And since I'm taking the case of minus pi to pi, I'm drawing only that part, and it is your work to do the other part because totally we have to check minus 2 pi to 2 pi interval. I'm only checking for minus pi to pi. Okay. And this is a graph of what? The y is equals to tan x. Now, in the same graph, I'm going to plot the graph of y is equals to x. Let's see what we are going to get. So you get something like this here. Okay. So which means in the if you cut it at minus pi to pi, if you cut it at minus pi to pi, in this interval it is meeting only at x is equals to 0, but already at x is equal to 0, we have concluded it is a critical point, right? So let us not worry about that. So which means in between minus pi to pi, you are not getting any other points of intersection, that is solutions, which means there are no critical points in minus pi to pi. But obviously, you have to check for the other case. Okay, let's do it right now, no problem, because maybe you will feel difficulty later. So let's take the other interval. X belongs to minus 2 pi to minus pi union pi to 2 pi, the remaining interval. And in this case, what happens is sin x and x will have opposite signs. So there you can write f of x is equals to minus sin x by x, but the equation is not going to change, right? Because whenever you equate the f dash of x value of this function to 0, again, anyhow, you're going to get same equation tan x is equals to x. Okay. So if tan x is equals to x, now which means again you have to draw the same graph, right? So let us try to extend the same graph and verify. Or if you want, I can draw one more graph also, no problem. But that is up to you. Okay, let's see. I'll draw the graph here itself. This is your value 2 pi, and I'm extending the same graph. Okay, so try to understand. I'm not going to waste much time. This is minus 2 pi here, but I have to extend the straight line y is equal to x also here. So let's do that. And this is your minus 2 pi to 2 pi. So let's cut it there. And now check at how many points they are meeting. So clearly it is meeting at one point here. I hope you're able to notice. I'm highlighting it. This is one point, and this is one more point here. Okay. So which means clearly in this case that we have taken, you're going to get two more solutions of f dash of x is equals to 0, which means these are also the critical points of the function f of x. So let's count, right, how many points we have got totally. Initially, we got x is equal to 0 as a critical point, and by using the logic, we have got x is equal to plus or minus pi as two more critical points. And then what about this graph here? By looking at the graph, we can notice two more extra critical points, right? That is why I told you the question is not easy. It takes some time, and definitely there is a high chance of making a mistake in such questions. Okay, try to be very, very careful and try to go through the question completely once again. And if you forgot any concept related or any tricks related to this differentiability, try to go through your respective notes. Okay, let's take the next question. And this question is again a bit lengthy. It's not difficult, it's just a lengthy question. But if you understand the logic behind it, definitely it's a moderate question. Okay. So look at that. Let x belongs to close to minus pi to pi, and be very careful with closed brackets and open brackets. Okay. So x belongs to close to minus pi to pi, and there is a set given in which elements x must be equal, satisfying the equation. Now let's write down the equation there. That is nothing but sine square x plus sin x into cos x is equals to a. Okay, first of all, what I'm going to do is I'm going to take this as a function f of x here. Because if you read the question, in this set, yes, we have to put the values of it, which is satisfying this trigonometric equation. The problem is we don't have the value of a, but more importantly, they gave you the values of a as what? Integer. Okay, which means first thing you have to find out the range of left hand side part, and then you have to find out how many values of a which are integers and also that are lying in that range. Okay, so let's do it very carefully. Then you'll understand perfectly here. But you know how to find out the range of a function, right? So we have different methods since it is a trigonometric expression. Either you can differentiate or also I'm going to multiply and divide by 2 directly. This is 1 by 2 multiplied by, this is 2 sine square x plus 2 sine x into cos x is equals to f of x, because the only reason is I can write this as 1 by 2 times of this 2 sine square x is 1 minus 2 cos x, right? And then similarly, this 2 sin x cos x is simply sine 2x here. So finally, what you can notice is we have a simple, well-known trigonometric expression here, that is 1 by 2 times of 1 plus sine 2x minus cos 2x. But we know one thing very well. Since here x belongs to minus 2 pi to 2 pi, which is covering the 2 pi interval, which is periodicity of this sin x and cos x, right? So in that interval, I can be very sure that in this given interval, I can be very sure that this expression will give you the range as what? Only between minus root 2 to root 2 because it is like a cos x plus b sin x, right? And then to that you're adding 1. So let's add 1 to that because you have 1 minus, right? So you have that to add 1. And then this is 1 minus root 2 to 1 plus root 2. And then you're again dividing by 2 here. So which means finally we have the range of f of x here. F of x belongs to closed interval 1 minus root 2 by 2 to 1 plus root 2 divided by 2. Okay, so let's try to approximate also, right? Because we have to find out the integral values of a which are lying in this range here. So root 2 is what? 0.1.414, right? And then if you make it, this will be minus 0.41 by 2, which will be approximately, I'm writing the approximate values here, minus 0.2. And again, 1 plus 1.4 will be 2.4. 2.4 divided by 2 will be 1.2. Okay, so this is the approximate range of the left hand side trigonometric expression. Okay, so which means if it is having a solution, this right hand side a also must be lying in the same interval, that is a belongs to roughly it is what? Minus 0.2 to 1.2. These are not exact values, 1.2 and minus 0.2, because they are only the approximate values because I have put root 2 is equals to 1.4 and have taken. Okay. And then here they said that a belongs to integers. So what are the only integers that are lying in this interval? Only 0, comma 1. This is very clear. So which means there is no other way. You have to write down the cases and solve both of them separately. Right? I just told you it's not a difficult question. It is a question made lengthy. Okay. So you have to solve case by case. Now let's take the case one. Let's take the case one, that is a is equals to 0. Now this is an easy case because if I take a is equals to 0, the given equation changes to sin x plus cos x is equals to 0. And since the right hand side is 0, it is easy. So I can say one case is sin x is equals to 0, other case is sin x plus cos x is equals to 0. Or else I can say directly tan x is equals to minus 1, tan x is equals to minus 1. And then if sin x is equal to 0 in the given interval, we have the values as what? X is equals to 0, comma, plus or minus pi, obviously. Let's do that. And then next, if tan x is equals to minus 1, this x values in the interval minus pi to pi will be what? X is equals to, one is second quadrant angle, which is 3 pi by 4. And then other one is the fourth quadrant angle, which is minus pi by 4. Okay. And finally, we have 5 solutions, right? 5 solutions in the case one. So let's mark it here. 5 solutions. This is only case one. This is not the final answer, only the case. Now let's take the case two. Now again, this is going to be somewhat lengthy. Okay. So you have to be accurate and also maintain your speed. Now, if a is equals to 1, the question changes to sin square x plus sin x into cos x is equals to 1. Okay. Now, once again, to solve this particular trigonometric equation, we have different methods. I'm going to follow my own method, and whatever is comfortable to you, you can do that. Okay. So, what I'm going to do is I'm going to multiply both sides by 2 so that I can write this as 2 sin square x. So, if it is 2 sin square x, once again, I can write it as 1 minus cos 2x and plus 2 sin x cos x becomes sin 2x, and which should be is equals to 2, right? Because you multiplied by 2 on both sides. And finally, what we have the equation here is the well-known equation again, sin x minus cos 2x, which is equals to 1. Okay. Now, obviously, you have different methods here. Either you can square on both sides directly, or also you can multiply and divide by root 2 and find out the solutions here. Okay. So what I'm going to do is I'm going to multiply and divide by root 2 because while squaring, you might get some extra value. So I'm going to avoid the squaring process here. So if I multiply and divide by root 2, this will be 1 by root 2 into sin 2x minus of 1 by root 2 into cos 2x, which is equals to 1 divided by root 2. But left hand side is very clear. It's because it is in the form of sin A cos B minus cos A sin B, right? Let us try to do that. So, so if I take this 1 by root 2 as cos of pi by 4 and this 1 by root 2 as the sine of pi by 4, I can directly write this as sine of 2x minus of pi by 4, sine A cos B minus cos A sin B, which is equals to 1 divided by root 2. Now it is a simple trigonometric equation that we know. What is our formula for sine x is equals to k? It will be n pi plus minus 1 whole to the power of n into alpha. Okay. Here in this case, alpha will be is equals to pi by 4 because we have the value as 1 by root 2, right? So let's write down the general solution. 2x minus pi by 4 is equals to n pi plus minus 1 whole to the power of n into alpha is clearly pi by 4, where here n belongs to integers. Now, what is your work here now? You will start putting n is equals to 0 plus or minus 1 and check for the values of x. Okay, n is equals to 0 plus or minus 1 plus or minus 2 and so on. And you won't get many values here. I think only 3 to 4 values you will get. Maybe like 3 to 4 cases you have to check. Remaining cases anyhow will not work out because it exceeds the given interval minus pi to pi. Okay. Now I'm leaving this solving part to you. And since it is a question from today's morning session, it is your work to do. Try to solve it and verify the answer. But anyhow, I'm going to give you the final answer, and I'm hoping you will do it and check the final answer. Okay. The final answer is actually 9, which means in this second case, this one, you will get 4 more solutions here. Okay. Now it is your job because I left only the simple calculation part of putting n is equals to 0 plus or minus 1 and so on. Okay. So as you can see, question is not a difficult one, already well known concepts to us, but the only thing is they have purposefully made it lengthy. Okay. So let's see the next question. And this is a question from permutations and combinations from the morning shift. And this is all not a difficult question, but it is one of the frequently asked questions. There are questions like this from the PYQs also, many of them. So once again, let's try to get more clarity for such questions and what is the process and how to obtain the cases here. Okay. Now the question is what? Number of 7-digit numbers, be careful, it is 7-digit number formed by using the digits 1, 2, 3, 4, 5 and at least once. This is the most important word here. Try to concentrate that it means that we have to use the digits at least once, which means the digits can be used multiple times also. Okay, so let's try to analyze how many cases are possible here. I will write down the cases one by one. The first case is obviously the case where exactly one digit is repeated. Exactly one digit is repeated. So what is the meaning of this one? I'll give an example also. Don't worry, don't worry. I'll give an example also. For example, I take let's say the number 1, 2, 3, 3, 3, 4, and 5. So let's count it 1, 2, 3, 4, 5, 6, 7. So clearly, what is the specialty of this number? It has 7 digits in total, but uh, how many times the number 3 is repeated? It is repeated 3 times, right? So we are going to concentrate on these kind of numbers here. Okay. So exactly one digit is repeated in this example. That is only 3 is being repeated. Now, first thing, what you have to do is you have to pick the digit which you are going to repeat in the number. Okay, because in this example that I have written the 7-digit number, I'm repeating the number 3. But is it mandatory? No, obviously, because you can repeat the number 1, 2, 3, 4, 5, anything as per requirement. Okay, that is why first of all you have to pick the number that you are going to repeat in that form number. So out of 5 numbers, you have to pick exactly one, which is 5C1. Now the picking of the digit is done, and which means the remaining thing is only what? Arranging remaining numbers here. So as you can see in this example, clearly how many digits are there? 7 digits are there, so it should be 7 factorial and divided by. But out of this 7, exactly 3 are of same type, which means it should be divided by 3 factorial. Okay. And if you do the proper calculation, you will get something like 4,200. You do the calculation by yourself. Okay. And then one more case is also possible. That is case 2. In this case, exactly two digits are repeated. Let's take an example. Suppose I can write something like this: 1, 2, 2, 3, 3, 4, 5. Observe carefully how many digits are there. 7 digits are there, but how many digits are being repeated? Two digits are being repeated because I'm repeating the digit 2 and also digit 3. Now, in this case, I'm going to take all such numbers. Now, once again, let's concentrate here. First thing here, is it mandatory that 2 and 3 must be picked, which are going to repeat? No, obviously. So, which means definitely you have to pick the two numbers or the two digits which you are going to repeat in the formed number there. So that is why out of the available five digits, first pick exactly two of them, which is 5C2. And then once the picking of the digit that you're going to repeat is done, the remaining thing is only what? Arrangement. How many numbers are there? Seven numbers are there. 7 factorial divided by, since two digits of one kind are there, by 2 factorial, and two digits of other kind are there, by 2 factorial, and which will give you the answer as what? 12,600. But my question is, is one more case possible? That is case three. That is exactly three digits are being repeated. Think about it. Take 5 seconds time and think whether case three is possible, where exactly three digits are being repeated. Obviously, no, because let's say I'm trying to repeat the digits one, two, and three. Suppose like this: one, two, two, three, three, and then four, five. What is the problem with this one? It is not going to be a seven-digit number. It is going to be what? An eight-digit number, okay, which is not possible. And moreover, in this question, you have to use all the digits at least once, and don't think that this type of number is possible. Some students might get a doubt here. I can take a number something like this: 1, 1, 2, 2, 3, 3, 4, and then it is also a seven-digit number. Read the question once again. What is that? Here they are saying we have to use the digits at least once. That's why I told in the beginning itself that the word framing at least once is important. Otherwise, some more cases are also possible. Okay, so it's an interesting question. Try to be very careful. Okay. Let's take the next question. And this is a question from Circles. And once again, this is one interesting question because if you get a proper idea, this question can be done in less than 2 minutes. But if you do not get that idea and if you do not observe that simple thing in the question, it's going to be a bit difficult. Okay. So let's try to observe carefully. A circle meets coordinate axis at 3 points. So coordinate axis and also circle are having 3 points of intersection, and moreover center is also lying in the first quadrant, right? So first thing, I'm going to draw a rough diagram, then I will draw a proper diagram. Okay, don't worry about that, because I'm going to make one important conclusion here which some of you might have already noticed, and for the rest of them, observe this carefully. Okay, and the most important word in this question here is equal intercepts. A circle meets the coordinate axis at 3 points and cuts equal intercepts, which means the x-intercept of this circle and also the y-intercept of this circle both are same. So let me take it as some 2a comma 2a. Now very clearly, this is a chord of length 2a. So exactly half of them will be a comma a. Similarly here also half of them will be a comma a. So clearly the center of this one is going to be a comma a here. Okay, I hope this is clear because it is a chord and this will be the perpendicular bisector of the chords to the center. Okay, now after knowing the center is a comma a, the main observation that you got to make here is the line joining origin and the center will have a slope of +1. Unless you know you make this observation in the question, it is going to be a difficult one and lengthy one. Okay, so what's the conclusion here? The line joining center and also origin here has a slope of 1, and that is important because look at the remaining part of the question. If it cuts the chord of length root 14 units on the straight line x plus y is equals to 1. The importance here is this straight line x plus y is equal to 1 has a slope of -1, which means when drawing the diagram, I have to make sure this line joining origin and center is exactly perpendicular to the straight line x plus y is equals to 1. Okay, now let's start drawing the proper diagram. Now, once we come to this observation, the question is a very simple thing because it just needs Pythagoras theorem, nothing else. And if you want more clarity, try to listen to this once again. Just now I explained, right? Okay, just you can go through that once again. Why it is slope is equals to plus one, and why that concept is important in the question. Okay. Now, first thing what I'm going to do is I'm going to draw the straight line x plus y is equals to 1. Something like this here. This is a straight line x plus y is equals to 1. And the center to be somewhere here. And we don't want the center. We don't want to find out the center also. Okay, don't start finding out center. And don't even try that. Now, next thing, we have made an important observation that the line joining origin and the center in this case is going to be exactly perpendicular like this. Okay. And then next, I know that the length of this chord here, that is, this is length point A, this is point B. AB is the chord length here, which is root 14. But since this is the perpendicular bisector, the line joining center and origin, I can say that this length will be exactly half of it, that is square root of 14 divided by 2. And I'm going to join this center and the point A, which will give you the radius of this circle at the smaller. Okay. Now, one more thing is, if I take this as point D, if you want to apply Pythagoras theorem in this right angle triangle that I have just drawn, you need one more thing, that is the distance is CD here. But can we find out that? We just think, yes, we can find out obviously. And what is the reason for that? Because once again, your observation, this is the radius. I'm highlighting it. You can notice this is the radius of the circle. And then here I can find out the length OD. I can find out the length OD here where O is the origin because we know the line x plus y is equal to 1 and I'm going to find out the perpendicular distance from origin to the straight line which will be modulus of 0 plus 0 minus 1 whole divided by root 2. OD length will be is equals to 1 by root 2. And now very clearly, if total OC length here is R and OD length is 1 by root 2, what is the remaining length CD there very clearly? It is going to be R minus 1 by root 2. Now you have all the dimensions of the right angle triangle. Let's go for Pythagoras theorem. R square is equals to root 14 by 2 whole square plus r minus 1 by root 2 whole square. And I think now you can solve the remaining question because it's a simple quadratic equation. R square is equal to, this will be 14 by 4 plus r square minus of 2r divided by root 2 plus 1 by 2. R square gets cancelled here and you can make the remaining calculation. 2 2s, 2 7s. And finally, root 2 times of r is equals to 4. That is r is equals to 4 divided by root 2. But is it the required part? Let's see that. We have to find out the square of the radius. Okay, fine, very good. So which means the square of this r square is equal to 16 divided by 2, which is equals to 8. Finally, we have got the r square value, which is equals to 8. Okay. And I hope you found this question very interesting because unless we make that observation here and forming that right angle triangle there and applying Pythagoras theorem, it is going to be a bit difficult. Okay, so try to go through it one more time. See the next question. And this is also not a difficult question because once again, if you recall the trick, obviously it is easy, right? So let's try to read the question. Let the midpoint of the sides of the triangle are given and we have to find out the incenter. You know how to find out the incenter of a triangle, right? We have the direct formula, pretty direct one. But the thing is, vertices of the triangle are not given. So let's see how many of you can recall the property of this triangle in this question. So midpoints are given to you. Let's take the midpoints like this. 5 by 2 comma 7 and 5 by 2 comma 3 and what is the one more point? 4 comma 5. Let's take the vertices as A, B, C. And what's our beautiful property that we have? Whenever we have a triangle whose midpoints are placed like this, x1 comma y1, x2 comma y2, x3 comma y3. Okay. So let's say I want to find out this vertex here. Look at that. Look at the diagram. If I want to find out this vertex, what you're going to do? You're going to add the coordinates of corresponding coordinates of these two, and you're going to subtract the opposite one. That is x2 plus x1 minus of x3, comma, similarly, y coordinates as well, y1 plus y2 minus of y. Similarly, if I want to get this coordinate here, what I'm supposed to do? Add these two corresponding coordinates and subtract the opposite one. That is x3 plus x1 minus of x2, comma, y3 plus y1 minus of y2. So this is your formula, and I hope you can understand how to find out the third vertex here. Now, let's use that property here. Observe carefully. I'm going to write it here. Vertex A, I'm going to write 5 by 2 plus 5 by 2, but I'll subtract the opposite one. Similarly, 3 plus 7 minus the opposite one, 5, which gives you what? 5 minus of 4, which is 1, comma, 10 minus of 5, which is 5. So one vertex is there. And then vertex C you have to find out, which means I have to add these two, 5 by 2 plus 4 minus of 5 by 2, comma, 7 plus 5 minus of 3. So this will cancel out, and finally 4 comma 9. We got one more vertex C here. Similarly, if I want to find out the vertex P, you know very well. Try to get that question and tell. Just 5 by 2 plus 4 minus of 5 by 2, comma, 3 plus 5 minus of 7. This gets cancelled. Finally, 4 comma, this is 8 minus 7, which is 1. So successfully, we have found out all the three vertices of the triangle. Now you know very well what to do, because you have the vertices of the triangle, and we have the standard formula to find out the incenter of any triangle. I hope you know that. If you want, I can write down that sigma ax1 divided by sigma of a, comma, sigma of a y1 divided by sigma of a. This is your formula to find out the incenter, right? You can do the remaining solving part and then try to find out the answer. Okay. As a practice, you can try to do it. Let's see the next question. And this is a question from vectors and one of the frequently asked questions from previous mains. Okay. So that's why let's try to do the question one more time so that we get a good practice. And if the question of this type repeats, we have to be in a position to do without any second thought. Okay, so let's try to look at this. The maximum value of 3 times of mod of 3a plus 2b plus 4 into mod of 3a minus 2b. Let's try to expand that first of all. We know the formulas very well for this one. So it should be 3 times of square root of, what is the formula for this? 9 times of mod a square plus 4 times of mod b square plus 12 times of a dot b. And then plus 4 times of, this is square root of again 9 into mod a square plus 4 into mod b square, and again minus of 12 into a dot b. But we have values of mod a and mod b. I'm going to substitute it here. So it is 3 times of square root of 9 into 4, which is 36, plus 4 into 9, which is also 36, plus again, I know how to expand a dot b, a mod a into mod b into cos theta, which will give you 6 into 12, which is 72 cos theta. And then similarly here also 4 times. So this will be exactly the same with a minus sign in between, which means 36 plus 36 minus 72 times of cos theta. Let's expand and try to observe what happens. 3 into square root of, this is, if I take 72 common, this will be 72 times of 1 plus cos theta, plus this is 4 into square root of 72 minus 72 into cos theta. Or else I can directly take 72 common, and I can write this as 1 minus of cos theta. But we know the formulas for this one. 1 plus cos theta is 2 cos square theta by 2, and 1 minus cos theta is 2 sin square theta by 2. But theta is the angle between the two vectors a and b. We know the range of theta to be close to 0 to close to pi, which means the range of theta by 2 is going to be 0 by 0 to pi by 2. I'll tell you why this is important. Okay, because sometimes students might go wrong here while doing this kind of questions. So it is square root of 72 into 2, which is 144, which is square of 12. So which makes it 36 finally. 36 into. Now the important thing, you're going to get actually square root of cos square theta by 2, which means you have to put it as mod of cos theta. And this is going to be 4 times of 12, which is 48 modulus of sine theta by 2. But because we know that these are first quadrant angles theta by 2, so in first quadrant, sine and cos are positive. Hence, you can remove the modulus sign. And finally, you can write down the expression as 36 into cos of theta by 2 plus 48 into sine of theta divided by 2. And you can take 12 common. And moreover, you know what to do here because they're asking the maximum value of this one, right? We know very well what to do here. Square root of 36 whole square plus 48 whole square. Okay. So even though you forgot about the modulus sign, you will end up with the correct answer here. But I'm just trying to remind you whenever we have that square root of x square, don't forget the modulus sign. Here you might be saved, but in other questions you might get into trap here. Okay. Let's take the next question. And this is from the chapter sequence and series. And one more thing, I'm not taking all the difficult questions at a time and all the easy questions at a time. I'm just taking it randomly. So if you see that three, four questions continuously are difficult, then don't think that the entire paper is difficult because you know that, right? Whenever they are setting the paper, definitely they'll make sure at least some 10 to 12 questions will be of easy range only. But since I'm picking the questions randomly here, it's looking like this. So try to be careful, right? So let's see the question, and it is one of the standard question from progression series. So what we have here is sigma k is equals to 1 to n, ak is equals to 6n cube. The main observation that you have to make here is indirectly this is given as what? Sn, because it is sum of the n terms, right? Now once you understood that, it is going to be easy. Sn is equals to 6n cube. But we have to find out about what? AK plus 1 minus of AK, which means I have to somehow find out the value of AN from here. Okay. So for that, we have the standard formula that is Sn minus of Sn minus 1 will be is equals to Tn or also An in this case. Right? This is our standard formula. So which means if I want to find out An, I need to calculate two things here. That is Sn, which is 6n cube minus of Sn minus 1 means replacing n with n minus 1. So which will be 6 into n minus 1 whole cube. I can take 6 common and the remaining part will be n cube minus n minus 1 whole cube. Now we know what to do here. It will be 6 times of n cube minus of n cube minus 3n square plus 3n and minus of 1. Clearly n cube gets cancelled. Finally the remaining part is going to be 6 times of 3n square minus 3n and plus 1. Okay, so this is your value of an here. So successfully we have found out the value of an, but the question is not over. Once again, they tried to make it lengthy here. So we'll take the value of an and substitute in the required part there. So which makes it sigma k is equals to 1 to 6. A k plus 1 here is nothing but 6 times of 3 times of k plus 1 whole square minus of 3 into k plus 1 and plus 1 minus of ak. What is ak here? It is 6 times of 3 into k square minus 3k plus 1 and whole divided by 36. And again, we have whole square to this one. Okay. So the only remaining thing in this question is a proper calculation, nothing else. Okay. It's a blind process from now because it is a proper calculation. So which is sigma k is equals to 1 to 6. So I can take 6 common here, right? So if I take 6 common, it is going to be 3 times of k plus 1 whole square minus of k square. If I take 3 common, and if I take minus 3 common, it is going to be k plus 1 minus of k, and then plus 6 minus 6 will be anyhow cancelled out. So let's leave that out. And then whole divided by 36 is also there and to the whole square. Okay. So you can cancel this out 36 here and you can solve the remaining part. You can notice here sigma k is equal to 1 to 6. I'm going to write it directly from which I'll be getting 6k here and plus 3 remaining. And what about in this case? You're going to get minus 3. So whole divided by 6 and whole square. It gets cancelled out. 6 also can be cancelled out. And finally, the remaining part is only sigma k is equal to 1 to 6 k square. Okay. So at one point, we were assuming that the question is going to be lengthy, but look at that the last step. It is reduced to a simple question, sigma k square, k is equals to 1 to 6. We know very well what is the formula, right? It is n into n plus 1 into 2n plus 1 by 6. So it is going to be 6 into 6 plus 1, that into 2 into 6 plus 1 whole divided by 6. And if you calculate it properly, it is going to be 7 times of 13, which is 91. Okay. So not a difficult one. You might feel it is lengthy, but it definitely is not if you do the proper calculations. Okay. Let's see the next question. And this is also one of the interesting questions which was asked today in the morning session. And moreover, all these questions are from the morning session only. I will do the afternoon session analyzation in the next video, definitely. Don't worry about that. And you can observe this question first. So it's a question from limits, obviously. So they are saying limit extends to this entire function is equals to m exists finitely. Let's concentrate here. Exists and also it is finite. And then we have to find out the value of a plus b plus m here. Okay. So first thing you have two variables, when two parameters a and b, which means you need two equations to solve the two unknowns. First thing is very clear because as x tends to 2, look at the denominator there. I'm going to write like this. Denominator tends to 0, right? Because if you put x is equals to 2, it will be 2, 2 minus 1, sorry, 1 minus 1, 0. And again, log 1 is also 0. So denominator tends to 0. But what is the well-known thing to us? When the denominator is tending to 0, and if the limit of that function is existing finitely, definitely the numerator also must tend to 0. Okay, so this implies the numerator, as limit extends to 2, must also tend to 0. Or else I can simply ignore this sign function, right? Because anyhow it is going to be 0. So this is equals to 0. Now I'm going to put x is equals to 2 here. That is 8 minus of 5 fours 20 plus 2a plus b is equals to 0. Finally, we get one condition. 2a plus b is equals to 12. So I have already one equation with me in terms of A only. So which means I just need one more equation, one more condition to obtain the values of A and B. Okay, so let's try to evaluate the limit now. What I'm going to do is limit x tends to 2. This will be sine of x cube minus 5x square plus ax plus b whole divided by. And then I'm going to rationalize the denominator here. Let's do the calculation in a rough. So if I rationalize, this will be root of x minus 1 multiplied by root of x minus 1 plus 1 whole divided by root of x minus 1 plus 1. So the numerator is going to be x minus 1 whole divided by root over x minus 1 plus 1. Okay, which means the denominator first term is going to be x minus 2 divided by root over x minus 1 plus 1. I'll tell you why this is important rationalization. And moreover, you have different methods to solve this question. This is just my method. I found it easy. And then next one is log of x minus 1. But what I'm going to do is I'm going to write this function like this. Look at this carefully. I'm going to write this as log of 1 plus x minus 2. Okay. I'm writing x minus 1 as 1 plus x minus 2. And then I'll try to divide and multiply by x minus 2. So that you see a basic formula here that log of 1 plus f of x divided by f of x form as f of x tends to 0. This is going to be 1. This entire value will be 1. So it is simplified now. That's the advantage. Moreover, here as x tends to 2, let's find out this value here because it is existing and non-zero. If you put 2 here, this is going to be 2 minus 1 square root plus 1, which will be is equals to 2. So I'm going to mention clearly here that this denominator value here is 2. And if that goes to the numerator, finally what we have is limit extends to 2 times of this is sine of x cube minus 5x square plus ax plus b and whole divided by what's the remaining part here? We have one x minus 2, we have one more extra x minus 2 here. I'm going to get x minus 2 whole square. Okay, now you know very well what to do. Since here we know that the input to the sine function here is supposed to tend to 0 because we have already made the conclusion there previously. So I'm going to multiply and divide obviously, that is x cube minus 5x square plus ax plus b, and again multiply x cube minus 5x square plus ax plus b. Now this is of the form sine of f of x by f of x, where f of x tends to 0. So again this is going to be 1. Now we have the most simplified version of the question, that is limit x tends to 2 times, which is x cube minus 5x square plus ax plus b whole divided by x minus 2 whole square. Now since it is 0 by 0 form, try to use the L'Hopital rule, 2 into limit x tends to 0, which will be 3x square minus 10x plus a whole divided by 2 times of x minus 2. Okay. Now you don't need one more differentiation because once again here denominator tends to 0 very clearly as x tends to 0, which means obviously the numerator also must tend to 0. So I'm going to do that as limit x tends to 2, 3x square minus 10x plus a must tend to 0. If I put that 2 here, this becomes 12 minus of 20 plus a is equals to 0. So finally we get a is equals to 8. But already we have one more condition there, right? So let's try to take this and put it here to obtain the value of b. So 2a plus b is equals to 12 was our condition. But if a is equals to 8, this becomes 16 plus b is equals to 12, which makes b is equals to minus 4. Okay. So we have found out both the values of a and also b, but we still need the value of limit, right? So for that, limit extends to 2. Let's come back to this. 3x square minus 10x plus a value is 8 whole divided by x minus 2. Let's start differentiating because it is 0 by 0 form. So limit extends to 2. This will be 6x minus of 10 whole divided by 1. Now put x is equals to x tends to 2 here. This will be 12 minus 10, which is equals to 2, which means finally we have the limit value also, m is equals to 2. Look at what we have to find out. We have to find out a plus b plus m. A value is 8, b value is minus 4, and then m value is 2, which makes the final answer as 6, right? So it's an interesting question, not a difficult one. Just the basic formulas of limits are required, nothing else. Okay. Let's take the next question. So this is a question from quadratic equations. Okay. So by looking at the question, okay, let's read the question first. If the roots of the equation x times of x plus 2 plus x plus 1 into x plus 3 and so on up to x plus n minus 1 times of x plus n plus 1 is equals to 4n are the values alpha and alpha plus 2. That is, roots are given as alpha comma alpha plus 2, but the problem is so many terms are there to expand, but we have to find out the value of 2 alpha plus 1. Okay. So let's try to do it in a simpler way, and don't think it's a lengthy question. It's definitely a simple question, but proper observation is required once again. So instead of expanding everything and try to separate the terms, I'm going to write on the general term. Okay, I'm going to use a sigma method here. Let's observe the general term, right? I'm going to write the general term as TR is equals to x plus r minus 1 multiplied by x plus r plus 1, where r will be is equals to r from 1 to n. It will exactly satisfy it. Observe carefully. If you put 1, you're going to get the first term. If you put 2, you're going to get the second term and so on. Okay, so this is your general term. Now clearly you can notice that totally n terms are there, which means the left hand side here in this question is nothing but sigma r is equals to 1 to n tr, which is nothing but sigma r is equals to 1 to n. Tr is nothing but x plus r minus 1 multiplied by x plus r plus 1. Now let's try to expand first of all left hand side, then we'll try to equate it to the right hand side in the given question. So sigma r is equals to 1. If you expand properly, this is going to be x square And then the constant terms are clearly r square minus 1 because r plus 1 into r minus 1. And then in the remaining x terms, if you take common, x into r plus 1, x into r minus 1, if you add them, it will be x into 2 times of r. Now just expand the sigma here. This will be x squared times of sigma r is equals to 1 to n 1 because x is a constant with respect to the sigma here. And this is sigma r is equals to 1 to n r square minus sigma r is equals to 1 to n 1 plus 2 into x is a constant again. So sigma r is equals to 1 to n r. Now, but we know the formula sigma of 1 is n. So this will be nx square. And sigma of r square is what? N into n plus 1 into 2n plus 1 divided by 6 minus of n and plus 2 into x into again sigma of r is n into n plus 1 divided by 2. So this will be cancelled out. And let's try to write down the proper quadratic equation here, which gives us nx square plus x times of n into n plus 1 and plus the constant term is n into n plus 1 into 2n plus 1 divided by 6 minus of n, and this value is given as is equals to 4n. So what I'm going to do is I'm going to take that 4n to the left hand side and then form the proper quadratic equation. Okay. So if I bring that to the left hand side, this becomes minus 5n is equals to 0. Now we have a proper quadratic equation here. Look at this. This is entirely constant term. Now, for this quadratic equation, if we observe carefully, the roots are given as alpha comma alpha plus 2. Roots are given as alpha comma alpha plus 2. And the more important part is try to concentrate on what is required here. We have to find out the value of modulus of 2 alpha plus 1. Okay. So you have to get the proper idea that you have to apply the sum of the roots here. Don't go for finding the roots of the equation. It will take a lot of time and it's very hectic. Don't even go for that. Simply apply sum of the roots of this equation here, which is alpha plus 2 is equals to minus of b by a, which is minus of n into n plus 1 divided by n. So n gets cancelled. Finally, this is alpha 2 alpha plus 2, which is equals to minus n minus 1. And finally, what we can do it here is 2 alpha plus n is equals to minus 3. So we want the value of modulus of 2 alpha plus n. Take it, substitute, which is equals to modulus of minus 3, that is equal to 3. Okay. As you can see, by looking at the question, you might feel it is a very lengthy question. But if you try to do it in this method by using sigma notation, and then the observation that only sum of the roots is required, but not the process of finding out the roots. Okay, so try to be careful and try to save your time as much as possible in the examination, right? So, right, these were the questions I wanted to discuss, which were somewhat tricky and some were frequently asked questions already from the previous mains question. So, I hope you have found it helpful. Okay, and I will discuss the shift to two, that is afternoon questions, in the next video, and I'll try to upload that as soon as possible. So before that, you try to go through this perfectly and make sure you understood each and every question and try to recall all the tips that I just gave you while solving the questions here. Okay, thank you.